Hello, I'm Paul Beckwith. I'm going to tell you a story about the jet streams and the Arctic sea ice and snow cover and the warmth up there and how the whole system is changing and give you some perspective on where I think it's heading. So pull up a chair, get a comfortable chair, grab some popcorn, and listen up, and I'll tell you a story about the changes in the Arctic. So about a year ago, just over a year ago, I did this video, Unprecedented Jet Stream Crosses the Equator. It went viral, about 430,000 views at the moment, and I just basically talked about how there was new behavior. The Northern Hemisphere jet stream was coming down perpendicular, almost at a 90-degree angle to the equator, crossed the equator, and joined with the Southern Hemisphere jet streams. And I was talking about how unusual this was. Now, this was attacked in the mainstream media rather viciously. I mean, basically they did this. They said, no good. I mean, my response was, this, right? And then I did a bunch of, okay, that's enough. Then I did a bunch of videos, to defend my position. So what's happening a year later? Well, the jet stream, not only is it crossing the equator, but it's doing it around the entire hemisphere. It's crossing the equator all the way around almost, as I pointed out in the last video. And what I'm really going to show in this video is how the Southern Hemisphere jet streams are basically starting to fill almost the entire Southern Hemisphere. So not only do the jet streams slow down and become wavier and increase the frequency, duration, and intensity of extreme weather events, but they're starting to space fill the entire hemisphere. So they're not really focused, tight jet streams any longer. What they are is basically high altitude winds that have loops and that have ridges and troughs and curves and whirls, and they end up filling the entire space in the hemisphere. And what is most surprising to me is in the Southern Hemisphere, we're seeing this. So let's have a look at the observation. So Google Earth Null School. Go down and click on Earth. Okay, keep it at air. Select 250 millibar and winds, and then click on Earth again. And you can move this, just drag this guy around. Look down on the North Pole. Okay, I'm just going to kill the lights. Okay, so what we're seeing here is you see, basically there's all kinds of things going on here. Here, the purple areas are high velocity. Okay, so you could just click on them and it tells you the wind speed, 195 kilometers an hour, 232 kilometers an hour. So what you can see is, and the green are about 66 kilometer an hour, 70 kilometer an hour, and so on. So if you look at the area of the Northern Hemisphere, this is Greenland here, we're looking down on the North Pole, you can see a lot of green, a lot of streaks, and the amount of blue area is not that large. Wait till I show you the Southern Hemisphere. So here you see the jet stream, very powerful, and then diverges. So it's green coming out because it's spreading out, and here it's converging on the other side. I mean, look at this. There's a very strong discontinuity here, divergent flow, convergent flow. This is a trough in the jet stream. What this means is the pressure will be low here. It'll be very stormy here. Low pressure is associated with storms. This is a ridge here, okay? So this will be cold because it's open. It's like a wall, so the cold air can just come down and fill in here. Over here is a ridge. It'll be warm, humid air coming up. And these things can be pinched off and break off and give you a complete whirl. And so we're seeing a lot going on. Now look at the rotation here right over the Arctic Ocean. It's counterclockwise. There's tremendous, of course, the air is coming here from lower latitudes right up into the Arctic. So this is very warm and humid air coming right up into the Arctic and being carried around here. So this will move the sea ice counterclockwise. Normally the flow in the Arctic is you have a Beaufort gyre going clockwise, and then you have transpolar drift bringing coming this way. So this is a totally reverse situation, which we'll see more and more of as we head rapidly to a blue ocean event. Okay, now let me show you the Southern Hemisphere. Okay, so we'll look right at the Southern Hemisphere. Now this is actually quite amazing. Look, notice the clear difference with the Northern Hemisphere. First of all, it's almost all like purple, right? You see purple and the red galore. Okay, now add the green, which is 50 to 60 kilometer an hour winds, on the edges of the jet stream, and basically you're filling almost the entire space in the Southern Hemisphere. You've got the blue area here. If you take the total area on the surface, remember it's a curved sphere, okay? If you take the blue areas and add them up together and take them as a fraction, eyeballing it, it's probably about 5% of the area on the surface of the Earth in the Southern Hemisphere is the blue areas, which have winds less than the green, right, which is 50 to 60 kilometer an hour. If we look here, 65 kilometer an hour, here, 58, look up here, 50 kilometer an hour, okay, here, almost no winds, very low winds. So if you take the surface area with greater than 50 kilometers an hour, it covers say 95% plus of the Southern Hemisphere. This is very unusual. What's happening is, the jet streams, it's winter down there, it's summer where we are in the Northern Hemisphere. The winds are supposed to get stronger in the winter and tighten up, and the jets should be focused, more narrow, and streams. Here, they're just spreading out in the horizontal direction, also presumably in the vertical direction too, although it's not clear. I have to look at that in more detail. So this is very, very unusual and bizarre behavior, and it's because they're wide and they're going all the way to the equator almost. They're to within 10 degrees of the equator. Let's have a look at the equator here. Okay, here's the equator, and I showed you this in the previous video. Okay, this is all so these are coming up to this is within about 10 degrees south here, this line here, right? And what you see is this is pulling air in these whirls, and that's crossing the equator almost all the way around, and that was the focus of the last video. So this is a key point in this video, that the jet stream behavior is taking us to a different regime, a different planet. Now it's spreading out. Not only does it slow down and become wavier, but it's spreading out and space filling the entire hemisphere. Okay, what's that doing to the sea ice? Well, I showed you that warm air coming across. It's basically slashed the sea ice in that region. There's a lot of images here. You can also see that counterclockwise rotation at the North Pole is dragging the ice around and moving it in a counterclockwise rotation. What this means, if it was rotating the other way, you're going to get ice coming through the Fram Strait. So there's not a lot of export in this situation because we've got the counterclockwise rotation because of the way the jet stream is dragging the air around. So this is quite a different regime. Okay, so now let me show you a couple other things here. Let's have a look at the volume of the sea ice. So this is the POMAS daily Arctic ice volume, and what it's showing here for 2017 is the red line going to August 3rd, so just a few days ago, is the red line. And look, it's tracking almost right on the purple line, which is 2012. So that volume is about, that's about 6.7. So 6,700 cubic kilometers is the volume of the sea ice. So what it's saying is that 2012 and 2017 are tracking right on. Well, let's have a look. Okay, so this is the Navy data. This is 2012. Okay, so let's focus on the sea ice. So this is what we have. Now I should point out the scale here. Okay, so the dark blue is about a meter thick. The lighter blue is about 2 meters thick. And if we go to green and up, it's 2.5, 3 meters and higher and thicker. Okay, so look at this here. We've got lots of 3 meter thick ice. We've got 4 meter thick ice. It's covering a fairly large volume. And now this is 2012, August 8, 2012. This is now August 8, 2017. And look at the difference. Okay, there's almost no sea ice that's thicker than 3 meters. It's all 2 meters and less. Okay, the total area is similar. Okay, the total extent or area is similar, but the thickness has been slaughtered. Okay, so tell me how that PO mass data, how can these be the same volume, right? There's something wrong with this model. It's calculating the volumes correctly. This is very misleading. Needs to be looked at carefully. There's no way that obviously there's a lot less volume here than there is here, because this ice is much thicker. The volume is the thickness times the area. So there's no way that the volumes are the same here. So that model is out to lunch. Okay? Also what we're seeing is this is total precipitable water, and what we're seeing is these streaks of water, these atmospheric rivers are moving closer to the poles. The Antarctica and Arctic are very cold and very dry normally, but because the Arctic's warming like crazy, a lot of moisture, water vapor is being carried up. Because the jet streams are all messed up, a lot of water vapor is being carried right up. Okay, you can see this water vapor being carried right up into the high Arctic. So let's have a look at the temperature. This is the North Pole looking down. Okay, anything blue is over this is zero or slightly below zero. Okay, on the top of the sea ice. The green is all above zero. So all ringing all around where there's no sea ice, it's above zero. In fact, it's, look, 5.6 degrees, 8 degrees Celsius. Very, very warm temperatures, in fact. We've been getting record high temperatures in Alaska and all around the border. Let's have a look at this is the amount of water vapor that can be held. So normally the Arctic is very dry. There's very, very little water vapor. It's like a desert. But look at this, we're getting lots of water vapor. This is kilograms of water vapor per square meter. We're getting lots of water vapor in the Arctic being carried by those jet streams which come right into the Arctic. Okay, let's have a look at this. Now, what is this? Okay, so what I've done is I've clicked on Earth. I've done particulates instead, and PM10 is particulate matter less than 10 microns. So this would be smoke from fires or dust blown up from deserts. Well, what do we see here? First of all, look on Greenland here. There's a source here. Okay, what's going on here in Greenland? You've probably read in the news that there's tundra, or some of the tundra vegetation on the outskirts of Greenland is burning. Okay, there's fires on Greenland and it's producing particles, and those particles are being carried by the winds. Okay, so that's what we're seeing there in Greenland. Okay, you can also see there's particulates here. There's lots of stuff going on there. Let's go down and look in North America. Okay, well, what have you been reading about? These record fires in British Columbia, and the smoke is being carried away. It's clouding over cities like Seattle. It's spreading out. Okay, these are hot spots where there's fires, but they're also from the deserts and stuff. Look here, we have the Sahara Desert. We have the dust is being blown, so those are dust sources here. So it's a combination of, you can go around the planet and you can see what's going on. One of the things that I don't understand here is, well, one of the interesting things is, we were looking at precipitation. So this is a climate reanalyzer. This is, if you go look at the temperature anomaly, okay, very hot here. And if you look at precipitation and clouds, there's actually rain on Antarctica, okay, right here. And there's also rain on, if you click this, there's also rain here over the Arctic. So it's raining in Antarctica.